Welcome back to Silent Reader Chemistry. In our last lesson, we learned what chemistry is. Today, we're exploring the three states of matter that make up everything around us: solids, liquids, and gases. Look around you right now. The device you're using is a solid, the air you're breathing is a gas, and maybe you have a drink nearby that's a liquid. Matter is anything that has mass and takes up space, and these three states have unique properties based on how their particles are arranged and move. Let's dive into what makes each state special and how they can transform from one to another. Now let's compare the properties of solids, liquids, and gases. Solids have definite shape and volume because their particles are tightly packed and vibrate in fixed positions with strong intermolecular forces. Liquids have definite volume but take the shape of their container because particles can slide past each other with moderate attraction. Gases have no definite shape or volume because particles are far apart, move freely and quickly with very weak forces. These differences explain why solids are hard to compress, liquids flow, and gases expand to fill their containers. Understanding these properties helps us use materials effectively in daily life. The differences between states come down to particle behavior according to the particle theory of matter. All matter is made of tiny particles that are always moving with spaces between them. In solids, particles vibrate in fixed positions with strong attraction. In liquids, particles can slide past each other with moderate attraction. In gases, particles move freely with very weak attraction. When we add heat, particles move faster, which can cause state changes. Evidence for particles includes diffusion where smells spread through air, Brownian motion where tiny particles jiggle in liquid, and how materials expand when heated. Matter can change states through phase changes when we add or remove energy. Melting turns solids to liquids by absorbing heat, while freezing turns liquids to solids by releasing heat. Evaporation and boiling turn liquids to gases by absorbing heat, while condensation turns gases to liquids by releasing heat. Sublimation turns solids directly to gases, and deposition turns gases directly to solids. During phase changes, temperature stays constant because the energy is used to break or form intermolecular bonds rather than increase particle speed. This is why ice water stays at 0 degrees Celsius until all ice melts. Temperature measures the average kinetic energy of particles and determines states for many substances. Everyday examples include ice melting in drinks, water evaporating from clothes, condensation on cold glasses, and freezing when making ice cream. Pressure also affects states. Increasing pressure can turn gases to liquids like in LPG cylinders, while decreasing pressure lowers boiling points, which is why water boils at lower temperatures on mountains. Some substances have interesting behaviors like water being less dense as ice, dry ice sublimating directly, and liquid crystals having properties of both liquids and solids. Beyond the common three states, other states exist under special conditions. Plasma is superheated matter with ionized particles found in stars and lightning. Bose-Einstein condensates form near absolute zero where particles behave as a single entity. Supercritical fluids exist beyond the critical point with properties of both liquids and gases. Even solids can be crystalline with repeating patterns or amorphous with random arrangements like glass. Understanding states of matter has led to refrigeration, power generation, materials science, food preservation, medical applications, and space exploration technologies. The best way to understand states of matter is through hands-on experiments. You can race ice cubes on different surfaces to learn about heat transfer, create a water cycle in a bag to see evaporation and condensation, observe gas expansion with balloons in refrigerators, make butter from cream to see liquid to solid transformation, or create baking soda volcanoes to produce carbon dioxide gas. Always follow the scientific method with questions, hypotheses, experiments, observations, and conclusions. Remember to always have adult supervision and prioritize safety in all experiments. Congratulations on completing our lesson about solids, liquids, and gases. We've learned about the three main states of matter: particle theory, phase changes, temperature and pressure effects, other states like plasma, and hands-on experiments. Remember that energy-absorbing changes include melting, evaporation and sublimation, while energy-releasing changes include freezing, condensation and deposition. In our next lesson, we'll explore properties of matter and distinguish between physical and chemical changes. Keep observing the states of matter around you and the phase changes in your daily life. Thank you for learning with Silent Reader Chemistry.